congruent to triangle CEG. Am I right? A, EF, and CEG. Okay, so let's say DBC, DAE, BCE. Okay, let's prove that. So what will be the first statement we're going to write here? Of course, we know the given, reason given. Okay, so the first statement here, we start with working on what's given. So it's given here that segment AD, side AD is congruent to side BC. So what is that? In a quadrilateral, properties of quadrilateral. So are you still there?
Yes, I'm still here.
So from this statement here, a segment AD congruent to segment BC, we can say AD is parallel to BC, right? Our reason would be because if two lines are caught by a transversal, so a pair of alternate then the lines are parallel. See? Which ones are transversal here? So we have AB, line AB, right? Side AB or line AB, if we're going to extend that, that would be line, and CD. So it would look like this to do that. Right? This is A, B, C, D. So it's like transversal. So if two lines are caught by a transversal, so that a pair of alternate angles are congruent. These are alternate angles. They're congruent. Then the lines are parallel. So there will be a reason. This is already given there, like that AC, DB, FC intersect at E. So a reason would be if two lines are cut. Did you say you want to try this? Why am I answering? So that a pair of alternate interior angles are congruent. The lines are parallel. Okay. Do you get that? Come on, are you still there?
Yes. Yes, I'm still here.
Okay, so it says that ABCD is a quadrilateral. And is it a parallelogram? Taking a look at the properties of quadrilaterals, you can take a screenshot of that. So
I got it.
since AD and BC are congruent and they are parallel, then that means ABCD is a parallelogram from the properties of parallelograms. Okay?
Okay.
Okay, so we can Our next, what's that? Our next statement would be, we can say ABCD is a parallelogram. Why? Our reason would be if one pair of opposite sides of a quadrilateral are both congruent and parallel, the quadrilateral, mine is very long. Quadrilateral, you just have to memorize that, is a parallelogram. Then the next one. Okay, so we've already proven the sides are parallel and congruent from the given statement. It's one pair of sides are congruent and they're also parallel, and that ABCD is a parallelogram. So what's next? How about the diagonals? So the diagonals here, we have AC and BD. We are interested in FEC, and because we need to we're going to prove FEA or AEF and then CEG. So we need to prove that those two triangles are congruent. So we need to prove that the sides and angles are congruent. So we can conclude that the two triangles are congruent. So what's next? So what are the sides that are included in those two triangles? A triangle FAE and CEG. So we have side AE from the diagonal of a parallelogram. So the diagonals of this parallelogram, they bisect each other. It's stated there from the given statement that AC, DB, and FG, they intersect at E. So and so we can conclude that AE, okay, is congruent to CE. Do you get that? Because the diagonals of a parallelogram bisect each other. Okay, so AE and EC here are equal, congruent. Therefore, angle, this one, angle FEA is congruent to angle CEG. They are vertical angles. So, okay. So angle FEA is congruent to angle GEC. So they are vertical angles. So we would have proven that one angle of one triangle is congruent to another angle. Yes, another angle of the other triangle. and then one side is congruent to the other side. And of course this one, the side here, is congruent to this side here. Therefore, we can conclude that triangle AEF is congruent to triangle CEG ASA. Now, do you understand that? Colin? Hello?
Yeah, I do.
Did you get that?
Okay.
Do you want to take a screenshot from the...
Yeah, I just took this screenshot.
Okay, this one and then this one. Okay.
Yeah, I got it.
We can solve another one. Another problem.
Okay.
So which one there you feel like solving?
So what problems are available again?
The problems I sent you. Which number would you want to solve?
Just like what numbers that are available that we did not do yet.
Okay.
Like what number do we not do yet?
So which one?
I'm asking which one do we not do?
We haven't done number, oh, we did number 3, number 9, number 10, we did that. We didn't do number 8, number 12, number 15, number 13, 17, because we did 14, 18, 19, 20. So which one there?
Let's do 8.
We
Are you
have,
there?
yes. We haven't done, where is that? Maybe we can do, how about number 13? Do you feel like doing that?
Yeah. Works.
13?
Yep.
Okay, let's do that. So where is 13? Let me draw that first. Maybe you want to try. So this says a quadrilateral. So that is A, B, C, and D. And then one diagonal here, AC, and then we have we have EF that looks like that, and then maybe this is a bit difficult. Okay, so G, H, and then E, F. So in the diagram of quadrilateral, so A, B, C, D is quadrilateral. Then diagonal AC. It's diagonal. Okay, segments GH, EF. It says that AE AE, why am I doing that? Segment AE is congruent to segment CG. Where is CG? There. Okay. And then segment BE is congruent to segment DG. And then segment AH is congruent to segment CF. And segment AD is congruent to segment BC. Okay. And then we need to prove segment EF is congruent to GH. How are we gonna do that? Okay, checking the given CG, BE, DG, AH, CF, AB, CB. Okay, so let's prove that segment EF is congruent to segment GH. So you want to try? Come on. Yeah. It's given that it's a quadrilateral, so you can take a look at on the properties of quadrilateral. Okay, first one given. Okay, we already knew which ones are given. So, okay. So a lot of given here. So all of this you can write here as your given. And then next is, okay. Oh. AC. So maybe we can use reflexive property here. This one, HF, is congruent to HF. So we can write segment HF is congruent to segment HF, and the diagonal AC is congruent to AC. So our reason is reflexive property. And then since they are congruent, we can use segment addition. Still remember the problems we worked on last time where we did segment addition. So since AC is congruent to AC and HF is congruent to HF, therefore we can say that AH plus HF is congruent to CF. Okay, let me just write that. Okay, so segment AH plus segment HF is congruent to segment CF plus segment HF, right? AAH plus HF is congruent to CF plus HF, and then AE here, this one, AE plus this one is congruent to, okay, I'll just write AE plus BE is congruent to CG, segment CG plus DG, because these two sides are congruent and parallel. So our reason would be segment addition. Okay. A, B, C. Okay, so now we have formed two triangles, right? Two triangles, triangle, okay, this triangle ADC, and then the other one is triangle ABC. So we can write here, this is what we did last time. So what's that, number 4. So for number 4, we can conclude that, because we have already proven the sides are congruent, right? This one, this side is congruent to this one by segment addition, and this one is congruent to itself, a reflexive property. Therefore, triangle ABC is congruent to triangle CDA. So side, 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 congruency. Okay? Then, what's next? So this one is congruent to that one. So therefore, by CP/CTC, congruent parts of congruent triangles are congruent. So therefore, the angles there are also congruent. So what are the angles that are congruent there? We have alternate interior angles, alternating. This one. Kawan. So, can you still hear me?
Yes.
So that therefore, angle EAF is congruent to angle GCH. So our reason would be congruent parts of congruent triangles are congruent. Therefore, triangle, this one, okay, this one, this triangle here, AEF, so we have small triangles inside the big triangles. Triangle AEF is congruent to triangle CGH. So we can write triangle AEF is congruent to triangle CGH. So side, angle, side. Do you understand why it's side, angle, side? Because this one is congruent to here. Oh, where was that? Okay. And then this one is congruent to itself, the AF, and then this angle is congruent to this angle. So our reason would be SAS. Then we're supposed to prove EF is congruent to GH. So EF here is part of the congruent triangles EF and GH. Where's GH? Here. Therefore, segment EF is congruent to segment GH. So congruent parts of congruent triangles are congruent. That's how we prove it. Now, do you get that?
Yes.
Good. I think you've already studied a lot for your exam. You can take a screenshot of that, and then this one too.
Alright, got it.
We can work on another problem. You want us to work on another problem?
Sure.
Okay, so which one here? Maybe I'll just choose. So maybe say number 19. Maybe 19?
Sure. We can do 19.
19, is that easy for you? Or 20? Which one there would you want? That you feel like you need help on?
Which screenshot is the problem on?
Number 20. Or maybe what numbers have I sent you? Which numbers? Maybe I haven't sent you this.
You only sent me
Did I send you 18 to 20?
I don't think so. I want to see 7.
Oh, so until 17 only?
Like, I mean, you sent me this thing. From like 1 to 17.
Oh. Let me try sending you 18 to 20. But you can still choose from 1 to 17. Whichever you like there, you feel like solving. While I'm sending 18 to 20. I've just sent you 18 to 20.
Okay.
But if that looks easy for you, then you can choose another one.
We can do, I guess you can do 18.
18?
Yeah.
Okay. Oh, these are what we did. Can you see what's on the live board? Like we did this last time.
Oh, okay.
Yeah.
I guess we can do.
Yeah, this is from our lesson last time. So let me draw that. It's a quadrilateral. Oh, how can I? Okay. So okay, and then, or maybe this is. It doesn't look like quadrilateral.
Oh, okay.
It's okay. It doesn't matter.
I guess we can do.
Sorry.
We can do 20.
Okay, we can do 20 instead. Okay. So that is a trapezoid, isosceles trapezoid. So, oh. So that looks like that. Then, okay. And then we have this one. then the one here. Okay, so that is A, B, C, D, and E. So A, B, C, D here is an isosceles trapezoid. Then the bases are D, DC, and AB. These are the bases. Non-parallel legs AD and BC. So AD and BC legs, non-parallel. Segments AE, BC, okay. ABCD, such that, okay. Angle CDE is congruent to angle DCE. Where is CDE? CDE, okay, this angle is congruent to DCE. Oh, yeah. Okay, then AE, segment AE is perpendicular to segment DE. Then segment BE is perpendicular to segment CE. So what are we going to prove here? Prove that triangle ADE is congruent to triangle BCE, and prove that triangle AEB is an isosceles triangle. Okay, so how are we going to do that? Statement, reason. So given, you can write all the given here. Your reason will be given. Okay, so we're given here an isosceles trapezoid ABCD. Okay, BC. So we can start on the legs of the trapezoid. Are the legs of an isosceles trapezoid congruent? So we can, right? From the properties of isosceles trapezoid. So we can say, right? Side AD is congruent to side BC. Can say congruent legs of isosceles trapezoid. Then from there and from the given, maybe my drawing should be like, this should be straight. This should be like, sorry, and this one, it should be, if it extends here, like, so from there it says that AE is perpendicular to DE, and then BE is perpendicular to CE, right? So we can conclude that angle DEA and angle CEB are right angles. This one. So we can write angle DEA and angle CEB are right angles. Right angles. Are right angles. So our reason would be perpendicular lines form right angles. Form right angles. Okay, and from there, therefore, since they are both right angles, therefore they are congruent. They are both equal to 90 degrees. So we can say that, okay, that's number 4, right? Angle DEA is congruent to angle CEB. Our reason will be all right angles are congruent. Okay, so will be the next one. I'll take a look at the drawing. So we've already proven that angle DEA and CEB are congruent, and then AD is congruent to BC. Okay, then C. CDA, okay. Okay, so therefore angle CDA is congruent to angle DCB. This one. Angle CDA, this angle here, is congruent to angle DCB. DCB, this one. So we can write that from the base angles of an isosceles trapezoid are congruent. So these are the base angles of the whole thing, the trapezoid. And it says it's isosceles. So we can write angle CDA is congruent to angle DCB. Our reason would be base angles of an isosceles trapezoid are congruent. Okay. And then from there, so we can do subtraction postulate here. Subtraction of angles. So angle CDA minus angle CDE. Okay, you can say angle CDA. Are you still there?
Yes, I'm still here.
Okay, are you are you in the live board? Okay, angle CDA minus angle CDE is just congruent to angle DCB minus angle DCE. You can say subtraction postulate. Let me see. Let me check. Let's check here. So angle CDA, okay, this whole thing here, minus CDE, this one, is just congruent to DCB, okay, this one, minus DCE, okay, so subtraction. Therefore, triangle ADE is congruent to triangle BCE. There is that. ADE. Triangle ADE. Because we've already proven this one. This side is congruent to this, right? And this one is congruent to... this angle is congruent to this angle here. So therefore... And this one, this angle is congruent to this angle here. So you can say that triangle ADE is congruent to triangle BCE by AAS, angle side. And then that means that this one, this side here, EA, is congruent to EB, right? Congruent parts of congruent triangles are congruent. So we can write segment EA or AE is congruent to EB. So congruent parts of congruent triangles are congruent. Therefore, angle EDA is congruent to angle ECB. Okay. Angle EDA is congruent to angle ECB. Let's say CPCTC. Angle EDA. Okay, this one is congruent to this one, and then this one is congruent to this one. Therefore, AEB is an isosceles triangle because triangle AEB has two congruent sides, and from the properties of an isosceles triangle, two sides or two angles are congruent. So we can say, therefore, triangle AEB is an isosceles triangle. A reason would be from the properties of isosceles triangles. An isosceles triangle has two congruent sides. Now, do you get that? That's a long one.
Yeah, very long.
Yeah. So, but do you get that? Do you understand that?
Yes.
Yeah, because it's already given that this one is an isosceles trapezoid. That means the base angles are congruent, and two sides are also congruent. So we can you can work on you can start working on from there. So okay, so you can take a screenshot of that. We just have to familiarize all of those.
Okay.
So what will be the next one?
I don't know. I think I was triple this.
Huh?
Um,
Did you mention you have a homework? What's that? Or no?
yeah,
Your homework?
yeah, going two proofs.
Are we gonna work on that?